All right, welcome back everyone. Okay, so what are we checking out today? Today we are looking at similar triangles. Similar triangles is what we also did in chapter number 2, so some of this should seem like review. Similar triangles are the same shape but not necessarily the same size. This was what we did when we had dilations back in the last chapter. So for them to be similar, two things have to be true. Number one, corresponding angles have to be equal measurement. Number two, corresponding sides must be proportional. And we saw one like this. Notice these are the exact same triangle, only I shrunk one. How do I know? Well, all the angles are the exact same. And when I looked at the corresponding sides, I realized that all their corresponding sides, the short side, 9 and 6, the long side, or the medium side, 12 and 8, and the long side, 15 and 10. When I set them all up in fraction form, they all simplified to the exact same fraction. So, here's the question. Are these two triangles similar? I don't know. I mean, this says 83 and 83, that's good, but this says 65 and that says 32. So how can I figure it out? Well, why not just find out what the missing triangle is for each? Or excuse me, what the missing angle is for each. Notice, for this triangle, we get 65 degrees. For this triangle, we get 32 degrees. So now, are they similar? Well, since all three angles are equal, yes, they are similar. What happened? We just rotated this one. All right, you guys. So you're finding that this one has a missing angle of 48, and this one has a missing angle of 42. Yes, they are similar. What about this one? You'll notice that these are not close, but not similar. Not all the angles match up. The 84s do, but the other ones do not. All right, we also learned how to be able to find the missing side. Remember, we always talked about big and small. So this is the small triangle, this is the big triangle. I have all my small numbers right here, and all my big numbers right here. I also have short and long sides on my triangles. Notice all the short sides are in the numerator and all the long sides are in the denominator. If I set this up properly, all I have to do is cross multiply. And I can find my answer. I can use that in some real life situations. I can use it to help measure things that aren't usually measured, like how tall is this flagpole? Well, I can measure a boy easily. He's 5 feet tall, and I can measure a shadow that he makes on the ground that's 3 feet tall. If the flagpole makes a 36-foot shadow, how tall is the pole? Do you notice the two triangles? Are they similar? Well, since the light is coming from the same sun, yes, they are similar. And we can set them up using a proportion. Do you see the triangles? All right, and if we set up our proportion properly, we cross multiply, divide, and we end up getting our answer, 60 feet tall. You can also use similar triangles, like this, to measure distance across a river. Notice this distance isn't the easiest thing to measure right here, but I can measure everything else on this side of the river. So what if we wanted to build a bridge? How wide is the river? Notice you can measure all of these. This is 45 meters, this is 18 meters, this is 16 meters, and we have similar triangles because these two angles would be equal because they are vertical. These two angles are equal, and if two of the angles are equal, we know the third one is equal. So I set up my proportion. I cross multiply, divide by 9, and I end up getting my answer. The river is 40 feet wide. Okay, so we're going to be practicing a lot with some word problems in this section. If you got any questions, make sure to ask me in class. And you guys, have a great day.